Hey, hi, all. Good morning. So, yesterday we have completed this in functions, and I have shared assignment as well. Do you have any question? No? Okay. I'm discussing only when the function is. So, I will start with Constraint. I have not covered. Have I covered or not? Constraint?
Covered.
Covered now. You already told you remember. So, let me start with correlated query. So, we'll explain correlated query with the help of one question. Okay, one example. So suppose you have this have this table. Here we have this data. Select the star from Y. In this from this employee table, suppose I have to find the highest, second highest, third highest. So if I will ask you the highest salary from this, you will answer this one, right? Correct.
Yes.
So how we are determining this as a highest salary? So for that, what we do actually, what our mind does is I will consider this as employee table, a lot ID, your salary, employee ID. So this is the table. Actually, when I'm asking find highest salary, you guys told me 600, right? So it means there is no one who can bid 600. This is the meaning of highest. No?
Yes.
Highest means there is no one who can bid this. That is the meaning of highest. Okay. So if I will compare, let's take each and every record. We'll start with this record. I want to check whether this is highest or not. So we'll compare with each and every record of this table, same table. Do you think 100 is greater than 100? No. 600 is greater than 100. Yes. We'll keep this in a bucket. 500 is greater than 100. Yes. I will keep it in a bucket. 300 is greater than 100. Yes. I will keep it here. 200 is greater than 100. Yes. I will keep it here. Right. Now, means these all values can beat 100. So how many records are there which can beat 100?
4.
4 records.
Mm,
It means if there is someone who can beat, it means you are not a topper. Right? That is the meaning of topper, no?
Yes.
So it means this 100 can't be a topper. Is this clear?
Yes.
Now, if similar analysis, if I will do for the next record, it is 600. Is this 100 greater than 600? No.
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 Is this 600 greater than 600? This is the same record, so ignore it. 500 greater than 600?
No.
No. 300 greater than 600? No.
No.
Is this 200 greater than 600? No. So there is no one who can beat this 600. Can we tell that this 600 is the topper?
Yes.
Is this clear approach?
Yes.
So actually, this is nothing new I taught you. This is what our brain does. If you want to find topper, you're searching for someone, a record which can't be beaten by anyone, and you will tell that yes, this is the top. Is this clear, everyone?
Yeah.
Yes, sir.
Similarly, if I'm asking, tell me the second topper. So to find a second topper, how many records can beat that?
At least one.
Not at least one, only one,
Okay. Now.
right? If I'm telling that Ramesh is the second topper, what it means? Ramesh has scored 95 and he is the second topper in the class. What it means?
There is only one person above him.
There is someone, right?
Yes.
Maybe Abdul is there who has scored 97. See, if I'm telling Ramesh is the second topper, it means there is someone who can beat Ramesh. Is this clear?
Yes.
Find the second topper. Actually, you're finding the record which which can be beaten by only one record. Is this clear? Yes or no?
Yes.
Yes.
This is nothing related to SQL I'm taking. This is a common sense. You all know, right? If I'm telling that Ramesh is the second topper, it is clear that someone is there who has scored marks greater than Ramesh, or Ramesh can be beaten by only one person, and that is Abdul. Clear or not?
Yes.
Yes, sir.
So now, if I have to find from here, which is the second topper, so let's start with 100. This 100 are same, so ignore it. Can this 600 beat 100? Can this bit see? Can the 600 beat this 100?
Yes. Yes.
Can this 500 beat this 100? Yes.
Yes.
This 300 beat this 100? Yes.
Yes.
This 200 beat this 100?
Yes.
Yes. How many records can beat this 100?
4.
4.
4 records, right?
Yes.
So can you tell that this 100 is the second top?
No.
Is this clear to everyone? Anyone who wants to repeat this? Okay, this is clear.
Clear, sir.
Let's take the second part. Let's check whether this 600 can be second topper or not. Can this 100 be 600? 600, 600, same ignore it. Can 500 be this 600? No. And 300 bit this 600? No. And 200 bit this 600? No. So no one can bid 600. Can you tell this 600 is second topper?
No.
No.
And this 100 bit 500?
No.
And this 600 bit 500?
Yes.
500, 500, same ignore it. 300 can bid 500? No. Can this 200 bit 500? No. So how many records can bid this 500?
One.
Only one. So can you tell that this 500 is second topper?
Yes.
Yes.
Understood the approach?
Yes. Got it.
Find topper. No one can beat, right? This is the meaning of topper. Find the second topper. Only one chord. To find the third topper. How many records can beat?
2.
2.
Two records can beat, right? Hope it is clear to everyone so far.
Yes.
Because the correlated query which I am going to teach is based on this only. If you have understood this 50% correlated query industry. Okay.
Okay, sir.
Now I will write a query here. Just ignore the query, don't try to understand it. You'll get confused. Just give me 1 minute, guys. I have to bring my keyboard. 1 minute. Hmm. Just fine. So I'm executing this query. What a fine. Yes. What means this the topper?
Yes. Yes.
Okay. So this is the query which I have written. Okay. Now, when I will write here 0, I will get the topper. Why to get the topper I have written 0 here?
Because there is no one above me.
No one can beat him, right?
Yes.
Correct. I know I have not explained that query. I will explain it. Just give me some time. Now to get the second topper, how many records can beat him?
One.
One.
Only one, right?
Yes.
So this will be one here. Okay. Is this the second topper?
Yes.
Get the third topper. How many records can beat?
Two.
You write here 2. Please check that query. Is this correct?
Yes.
Do you think 300 is the third topper?
Yes.
Okay.
Yes.
It means in this query, just you change this value. If you want the topper, you give it 0. Why 0? Because no one can beat that record. If we want the second topper, keep it 1 here. Means only one record can beat. If you want the third topper, keep it 2 here. Means only 2 records can beat. Hope it is clear.
Yes.
Now we will try to understand what is happening in this query. Okay. When I executed this query, so actually this query has 2 parts. This is the first part. This is the second part. Okay. When the first part, blue color is green. If I will tell you what is the meaning of till here, what is the meaning?
Like we are selecting ID name and salary from table A. Employee.
It is clear that from someone has joined through the name NG. May I know, and please tell me.
Tanvir,
Sir, right?
yes,
Okay. ठीक है.
I joined it from another laptop. So
ठीक है. So if I'm asking you from here till here, what is the meaning of this query?
Displaying the record, ID, name, and salary from employee table.
This is clear and simple. That from employee A table, we are telling SQL engine to display ID, name, and salary. Right? This is clear to everyone.
Yes.
Okay.
Yes.
If I will proceed further till here, suppose I'm telling till where only, then what is the meaning of this query?
There is a filter condition.
We are putting a filter condition for selecting ID, name, and salary from
Employee.
Any other thought? It is the task of where clause.
to filter data.
Filter data.
Filter data, right? So if I'm telling select ID, name, comma, salary from employee A, this is clear that from employee A table, I need ID, name, and salary. But if I'm keeping where, it means I am telling SQL engine that SQL based on some filter condition, you fetch me this data, correct?
Yes.
Yes.
That is the meaning, no?
Yes.
So far, like wherever I have used where clause, that is the meaning. I'm telling SQL engine that if this condition is satisfied, then fetch me the data. If it is not satisfied, you might have seen engine will give no data found, right?
Yes,
So
sir.
here again, the meaning is same. We are telling SQL engine that after where there is some condition. I'm not talking what is this condition. But if I'm talking till here, it means I'm telling to SQL engine that there is some filter condition. If that is satisfied, then fetch me the output. If it is not satisfied, don't fetch the output. Correct?
Yes.
Clear? Okay. If I will tell you to read till here, till 0, then what is the meaning? Then the meaning is I'm asking SQL engine to display ID, name, and salary from employee table based on a filter condition. And in the filter, I have given 0. It means if this output bit, if this query output is 0, then do you think the filter condition will be true?
Yes.
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 Which means I'm telling to the SQL engine that if the output of this query is 0, then they both will be equal. This is 0, and if this is also 0, then the condition will be true. Then only display the record. So is this clear?
Yes. Got it.
It is clear to everyone so far?
Yes, sir.
Now the question is, what is happening in this query? The blue one. What is happening here? Right? What is the meaning of this? So we'll try to understand. In this query, if I will ask you the meaning till here, what is the meaning?
We are selecting distinct salary from employee B and like counting the number of repetition.
Or the meaning of this count of distinct salary from employee B is from employee table, we have taken the copy which is B. I'm trying to find the distinct salary, right?
Yes.
So how many distinct salary do we have in this employee B?
5.
5.
5. Do you think this filter condition will be true?
No.
No.
No. But here I'm telling SQL engine to find count of distinct salary from employee B based on some filter condition, right?
Yes.
Right now, I'm telling SQL engine to find count of distinct salary from employee B. If this condition is satisfied, then only count. Correct? Got it?
Yes.
So now see how this query will be executed. This is your employee A, this is your employee B. Engine will start execution from the outer query. Outer query is employee A. This is the one. Now engine will think that whether it has to display this record or not. So to display this record, engine will take this 100. Now what is this 100? This 100 is A dot salary. Got it?
Yes.
Now to display this record, it has to satisfy this condition, right?
Yes.
This is how your SQL engine works. It picks each and every record. It will check the condition. If it is satisfied, then it will give the output. If it is not satisfied, it will not give the output. You know this, right?
Yes.
So now engine has picked A dot salary, which is 100. It will check this condition. If it is satisfied, it will give the output. If it is not satisfied, it will not give the output, right? Okay. Now then engine will start executing this inner query. In this inner query, you're telling to count distinct salary from employee. It means from this table to count distinct salary, but based on certain conditions. What is the condition? This is the condition. B dot salary should be greater than A dot salary, right?
Yes.
Then engine will check each and every record of B dot salary. Do you think this 100 is greater than this 100? No. Next record. Is this 600 greater than 100?
Yes.
Yes. Is 500 greater than 100?
Yes.
300 greater than 100?
Mm.
200 greater than 100? Yes. So now these all are the salary which is satisfying this condition. Is this clear?
Yes.
This is clear. So
Yes,
what
sir.
will be the count of distinct salary?
4.
It will be 4,
Mm.
right? Be 4. So now what engine will do in this query? Engine will tell that the output of this inner query is 4. Okay. Now, do you think this condition is true?
No.
No, this is not true. This is false.
Mm.
Do you think you will get this in the output?
No.
So is this clear how this query is getting executed?
Yes.
Then engine will reject. Okay, this will not be displayed. Let's reject it. Then what next?
It will take 600 from employee and then
Then this then this outer query will pick the second record. This one. Now A dot salary is how much? 600. Okay. Now this outer query will tell to the inner query. Now I have this A dot salary. Please evaluate the condition. Then this inner query will again start checking this condition. Inner query will check for each and every record. Is this 100 greater than 600? No. Is this 600 greater than 600? No. Is this 500 greater than 600? No. Is this 300 greater than 600? No. Is 200 greater than 600? No. So there is no record. What is the count of distinct salary?
0.
0. So now this query, inner query will tell to the outer query that my output is 0. Now this outer query will check the condition. Is this condition true?
Yes.
Yes. Then engine will display this. Is this clear?
Yes.
So here see how your outer query and inner query is working in perfect synchronization. Correct? Outer query is picking a record, then inner query is checking the condition, and the inner query is giving its output. Based on the output, outer query is taking decision whether to display or not. Then outer query is picking the second record. Now for the second record, again inner query is checking the condition and it is giving its output. Then outer query is deciding whether to display or not. Is this clear, guys?
Yes.
I'm waiting for your response.
Yes, sir.
Yes.
Here, everyone?
Sir,
Yeah.
sir, I'm asking that you haven't mentioned salary in the employee in the outer query, but then how will you select the 100 from employee A and then use the inner query for that?
Actually, first of all, outer query will be executed, this red one. Okay.
Because
So
in the
in
filter
the
condition, salary is not there na in the outer query. That's why I'm
so
asking.
that's based on doing outer query, no, this red color. It will pick each record of this table employee. First of all, it will pick this record. You are correct. I'm not given salary 100, but this is how SQL works, right? It will take each and every record. Correct. So it will pick this record first, and it will check whether this condition is true or not. Then it will take second record, then it will take third record, then it will take fourth record, then it will take fifth record. It will check this condition for all the records. I've shown for 100, I have shown for 600. For 100, this condition was failed. So this record will be rejected. For this 600, this condition was passed. So this is displayed. Now engine will check for the next record, this one. Is this clear, Shani?
Yes, sir.
Then it will take the next record. Now what is A dot salary?
500.
500.
Salary is 500.
Hmm.
Now again, inner query will check the condition B dot salary greater than A dot salary. Now, outer query will just give the record. Inner query will check the condition. Now, do you think 100 is greater than 500? No.
Yeah.
No, sir.
600 is greater than 500?
Yes.
Yes. 500 and 500 are same, ignore it. 300 is greater than 500? No.
No.
200 is greater than 500?
No.
So this is the only record. Now, what is count of distinct salary?
1.
1.
1. Then this outer query will tell to, sorry, the inner query will tell to the outer query that as per my analysis, the output is 1. Then the outer query will check whether this is true or false. Is this true or false?
False.
False.
False, because 0 is not equal to 1. So
Hmm.
this condition is false. If it is false, then the outer query will tell, sorry, I cannot publish this. Got it?
Yes.
So
Yes, sir.
here you have to understand the synchronization between outer query and inner query. How in a perfect synchronization they are working. Outer query is picking a record. Inner query is checking the condition. inner query is giving its output. Then outer query is taking a judgment whether to display or not. Right? Then the engine will go to the next record. Outer query will go to this record. Now, what is A dot salary? 300.
300.
This outer query will tell to the inner query. Now, A dot salary is 300. Please evaluate your condition. Then inner query will again start its engine. It will check B dot salary greater than A dot salary. Is this standard greater than 300?
No, sir.
No. Is this 600 greater than 300? Yes. Is 500 greater than 300? Yes. 300 greater than 300? No. 200 greater than 300? No. So what is the output of counter distinct standard?
2.
2.
2. Then this outer query will tell to the inner query that my output is 2. Then the outer query will evaluate this condition. Is this true or false?
False.
This is
False.
false, right? This was also false. This is true. This is false. In the outer query will take a judgment that okay, this is false, so will not display it. Are you understanding?
Yes.
Yes, sir.
So why I have picked this example, the main intention is to show you, to explain you that what is a correlated query. Here the name correlated has been derived from the word correlation. There is a correlation between outer query and inner query. Understood?
Yes.
You're understanding now how it is like there are two persons sitting within your machine. This is outer query, one person, inner query is another person. He is telling to the inner query that hey, I have this new record. Please check the condition. Inner query will quickly check this condition. It will find count of distinct salary. It will give dot. Then outer query will take a judgment. So it is like two person are sitting behind and they are checking this condition one by one, one by. Hope it is clear.
Yes.
Similarly, then engine will go to the next record, this one, and it will perform its operation. Hope you understood, guys.
Yes.
Yes, sir.
This is correlated. Now here we're finding the topper. Now if you want to find the second topper, then what you will do? Instead of 0, you have to write here 1. If it is 1 means only one record can be, then it will be a second top. This is that's what I have given here 1. The second topper is C. Or third topper you have to write here. But it's clear.
Yes.
Now tell me if you have to find the 10th topper. What you will do in this case?
We have to write 9. Include
9.
Yes.
10th topper means 9 records can be him.
Yes.
Okay, so now if the interviewer is asking you any number, can you solve this question? If it is asking, tell me the 50th topper. What you will keep here?
49.
49.
Mm,
The general formula is
-1. Basically.
-1. You're right. N minus 1.
Mm,
If he is asking 100th topper, 100 minus 1, you have to keep it 99. Is this clear, guys?
Yes.
So this is correlated query. This is one of the complicated concept of SQL. I will request you to again go to the recording and I will share few questions. But this is correlated query, recursive city, pivot. This all you will understand properly when you will practice few questions. Okay. But just by going through the recording and working on one or two questions, still there'll be confusion. So you have to practice more questions, then it will be easy. But generally in interview, they rarely ask question from correlated query, but sometimes they can ask from this as well because generally very few candidates they know what is correlated query. Okay. And even in your project, if you're working in project, so there are very few instances where you will be using correlated query. Okay. But I thought that maybe in interview, the interviewer will ask, but in the interview, if interviewer is asking this, and if you're explaining the way how I told you each and everything, you will get a very good rapport during the interview process. Okay. Now I have a question. Can you think and tell me the performance aspects of this query? Is this good from performance or bad?
Bad.
Bad.
Bad, of course. Why? Because there is a lot of to and fro is happening here, right?
Yes.
See, when you will go to a government office, not sure how many of you have visited a government office, any government office, LIC office, or any other bonds office. Okay. And if you have to get a task done, you know, a lot of steps will be there, right? You have to go from one person to another person. Then he will check the report. He will sign. If he is not there, you have to wait. He has went for lunch. Again, you have to wait. If he is on leave, again you have to wait, right? So these all things happens. So you have to go to multiple tables, different levels of a different hierarchy will be there. You have to visit all those hierarchies. It takes time, right? Same thing is happening here. A lot of to and fro is happening here. This outer query cannot take judgment. So we'll ask inner query to give the output. Inner query will give its output. Then based on that output, outer query will take a judgment, right? So for one record, how many to and fro is there? And suppose if you have millions of records, so how many to and fro will be there? And moreover, for each record, this inner query has to perform this task. It has to compare this with this one. Then it has to find count of distinct salary. Then it will give the output. Then outer query will compare and will take the judgment, right? That's why correlated query is not good from performance. Okay. Then you might be thinking that why we are studying it. So the reason is many business requirement. Okay, you can solve easily using correlated query. At the beginning of your course, I have told is that top priority is given to the requirement, then performance. Okay. Hope you understood correlated query, guys.
Yes.
Yes.
Okay.
Yes, sir.
Good. Correlated query, I have completed. We completed independent query. Then yes or no? Yes, we have completed. See, let me give you a few example. Not sure where I have covered it. But let me give you one example of that. Suppose in the same question here, okay, Is my voice audible?
Yes.
Yes, sir.
Suppose in the same question, same data, if the question is to find those employees whose salary is greater than the salary of D. Understood my question?
Yes, sir.
Find those employees whose salary is greater than the salary of greater than the salary
D.
G. So we will write the salary of the 300. Please tell me, is this the correct output?
Yes.
You all agree this is the correct output, right?
Yes.
Or do you think this is correct query?
No, we are hard coding the value.
You are hard coding. How
Mm,
you came to know that the salary of D is 300? We have checked in this table, right?
Yes.
Suppose tomorrow the salary of D has changed. So again, you will give the new value. That is not allowed.
Mm,
For that, you have to write here, select salary from employee where name equals D. Is this correct output?
yes.
Is this query clear?
Yes.
So here what I am doing, I am telling SQL engine to fetch me those ID name and salary from employee table where salary is greater than this query output. So what is the output of this? So what will engine do here? Engine will first of all execute this query. This is 300, right? Then engine will convert this query like this. And then engine internally will execute this query. This is known as independent query. But it's clear.
Yes.
Now, can you tell me why this is known as independent query?
Execution of internal and external not dependent on each other. Like they are giving like independent result and then solving their query.
Here, do you think this inner query is dependent on the outer query?
No.
No.
Now, check this one. Do you think this inner query is dependent on the outer query?
Yes.
Yes.
Yes. Here it is comparing B dot salary greater than A dot salary. So from where you're getting this A dot salary? Outer query, no?
Yes.
Right?
Mm,
That is why this is correlated and this is independent because inner query is not dependent on the outer query. That's why the name is independent query. Okay, now from performance perspective, which one is better, independent or correlated?
Independent query.
Independent query is better than correlated. Hope it is clear to everyone.
yes.
Tanvi, there's one question I have here. Hello.
Yeah, Mesh, tell me.
So first the inner query will execute, right?
Here.
In the previous example, where we are finding the first and second and third toppers and all. So there we were saying like the one question arises that how the inner query will get the A dot salary because That is the
Oh,
first the inner queries. If we were discussing that the outer query will be executed. So
mhm.
a little bit of confusion here, I think this.
See, when you executing this query, okay, let me explain the execution one by one. This is the query, and this is the table. Okay. Now you are executing this query. First of all, the execution will start from outer query only. You are trying to display name and salary from employee, but based on some condition, right? So engine will pick this record and it will check whether to display or not. But to display this, engine have to check this filter condition, correct? Got it? Now for this filter condition, the engine will execute this query, inner query. When
Hmm.
the engine will execute the inner query, what will be the output? 300,
Right.
right? Then engine will check this condition. Is this 100 greater than 300? No, this is rejected. The engine will go to the next bit, 600. Is this 600 greater than 300? Yes, this will be displayed. Hope it is clear.
Yeah. So
The
first,
next record is the hmm,
the outer query will execute, right? Always.
it will always it starts from the outer query, but here this inner query will get executed. It will check for this first condition, and then this inner query will be executed. That's all.
Mhm.
Then outer query will check for each and every record. Okay, is this clear?
Okay. Right. Okay. Yeah. Thank you.
Oh, no issues. So this is your independent query and correlated query. Hope you all have understood. So it is 8:05. Let's take a break for 5 minutes. Is that sufficient? Okay.
Yeah.
We'll be back at suppose 8:11. Okay, fine. Okay, I think we should proceed now. Hope I'm audible.
Yes, Tanvir.
Oh,
Sir, sometime we write query in a from clause. So for that query, any specific name? Hello.
hello, can you hear me?
Yes, sir.
Okay.
Sir,
Fine.
sometime we
Mhm.
write query in from clause, or I saw one time in select clause also. So any specific name for that query?
Subquery.
Okay.
Uh, Let me show you that. Um, I think one example I have shown earlier. After from, I have given a query,
Yes, sir. Yes.
right?
Yeah.
That is an example of subquery. Okay.
Okay.
After from, I think I have shown. I'm not getting any question which I should show you now. But yes, after from you can write a query, and that will behave as a table. If you remember, I have told that okay, now this table, this output of this query will act as a table.
Yes, yes. You shown, sir, already. Yeah. It is called subquery
Maybe
only.
yeah. I'm planning to take few topics in the ad hoc session in the alumni group. Okay. I will invite everyone there, like and subquery some complex examples. But for that, first of all, we have to practice all this fragment question a little bit clear. And then in Windows functions, if duplicate is there, proceedings of it, that I will take. If you guys are not able to attend, we'll share the recording, but I will suggest please attend it. Anyway, let's proceed further. Alter label this pivot. Now, these two are the important topics: recursive city and pivot. All other are simple. We will see one by one. Okay. We'll start with alter. So alter is very simple, but you will not get any questions in interview from alter. Only 5% chances are there. Even less than that, the interviewer can ask you question from alter. So generally, they never ask questions from alter. Okay. And this alter is used only by the data engineers, sometime, rarely. Okay. What is the functionality of this alter is it can modify the structure of this table. Like suppose I'm creating this employee table. Okay. I'm creating this employee table. Before this, I should teach you this one. One minute. Let me cover this one first, okay? Then I will cover the alter. This is family key. Any idea what is a family key? Anyone?
Uniquely identifies a row.
I have not covered family key, right? Nothing.
No.
No.
Primary key is that column for table which doesn't have duplicates. So no duplicate, no null. Okay. Like a very good example is your Aadhaar card number. Have you seen two person having the same Aadhaar card number?
No.
Not possible, right? Have you seen anyone with Aadhaar card not given blank or null? No, right?
Mm,
So the columns, the values which doesn't have duplicate value and no null are primary key. Aadhaar card. Then any other example?
PAN card.
PAN card. Voter ID card.
Mm,
Okay. Your driving license.
Passport.
These all are example passport. These all are example of primary. Hope it is clear. Suppose I have this employee table and I have employee ID, employee name, salary. So 1, 2, 3, 4. Emails of the Rajesh, Suresh, user. Now in this, which column is a primary key? Come on, tell me. Which column is a primary?
Salary and employee ID column.
Here, all employee ID. Do you have any duplicate?
No.
No, sir.
Do you have null?
No.
No, sir.
Employee name. Do you have duplicate?
No.
No, sir.
Do you have null? No.
Mhm.
Similarly, in salary, there is no duplicate, no null.
Mm,
So all these columns are satisfying the conditions of a primary key. Correct.
Yes.
So if the columns which are satisfying the conditions of a primary key, they are known as candidate key. They are known as candidate key. If I ask you that in this employee table, what are the candidate key? What you will answer? Employee ID, employee name and salary. They all are candidate key. Why? Because they all are satisfying the conditions of primary key. Got it?
Yes.
Now suppose if I have one more column, location. This is Delhi, Chennai, Pune. Yeah. Now, do you think this location column is satisfying the conditions of a primary key?
No, sir.
No.
No. So location, can you tell that location is a candidate key?
No.
This clear?
Yes.
Now, these three are satisfying the conditions of a primary key. But you can assign any one column only as a primary key. Okay? This clear?
Yes.
Understood primary key, guys?
Yes.
Yes, sir.
Okay. Now suppose I have one more record, 5. Okay. And this is John. And this is Abdul. This is 200. This is Delhi. Now this is Pune. Now suppose if this is the data. Do you think employee ID column is satisfying the conditions of a primary key?
Yes.
What about employee name?
Not satisfying.
No, we have duplicate, right?
Yes.
You all know it is possible that in a company you can have two employee with the same name, right?
Mm.
So now this employee name is not satisfying the conditions of a primary key. So we cannot tell that this is a candidate. Clear?
Yes.
What about salary?
Not satisfying. Duplicate record.
And we have duplicate report, right? 200 and 200 location as well.
Mm,
Now only employee ID satisfying the conditions of the family. Hope it is clear.
yes.
Yes, sir.
Okay. Right. Now, suppose suppose another example. This example I have given in the weekend batch. This one is a very good example I have given. Let me check what was the system yet. That apartment example I have given. Strong, very strong. It's a very good example. Hmm. In this table, you have a building table. Can you tell that this apartment name is a primary key?
No.
No. You have duplicate, right?
Mm,
This is Greenview is duplicate, Garden City duplicate, New Heights is duplicate, right? Okay. Can you tell this floor column is satisfying the conditions of a primary key?
no.
No. Flat number?
Mm,
No, right?
No, sir.
So then in this table, which column will be your primary key?
All three combined.
Single no column is a primary key, no?
No.
No. So it is possible that in a table, you will not be having a primary key. Okay. It is not mandatory that each and every table must be having a primary key. No, it is not mandatory. But yes, it is suggested, it is strongly recommended that when you're designing a table, it should have a primary key. But it is not mandatory. Is this clear? Like, see, it is strongly recommended that you should wear helmet and then ride bike. Correct. But even if you're not wearing helmet, you can ride a bike. Correct now? The bike will start and everything will work normally,
mm,
right? So same thing. It is strongly recommended that family key should be there in a table. But again, it is not mandatory. Even if you don't have a family key, you can create a table which can insert that will you can write queries, everything will work. What is clear so far?
Yes, sir.
Now, in this table building, we don't have a single column which is satisfying the conditions of a family key because we have duplicate, we have seen. But in certain situations, you have to create a primary key. Then what we will do? We will check the combination of two columns. So if I am telling you to take the combination of apartment name and floor, so do you think this combination can make a primary key?
no. There are duplicate records.
Let me delete this. This green view 1 and green view 2. Are they duplicate or distinct?
Distinct.
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 Mm,
So this two column combination, you will see all the records are distinct. Correct? Clear?
yes.
Then if you're taking two column combination to make a primary key, then it is known as composite primary. The same thing happens in your election, right? So next year we have election. So when you will see a single party doesn't have that required number of seats, then what they will do? They will make a coalition government, right? right?
Yes.
Yes.
They will make a coalition government. Your UPA, what
NDA.
is that? That is a coalition government. NDA,
Mm,
that is a coalition government. They
yes.
are they're combining with other parties to make that to reach that number. I think in Lok Sabha you have something 270, 272, something like that, right?
Yes.
So they make a coalition government.
Mm,
Currently, I think in Maharashtra you have a coalition government, right?
yes.
And then in Bihar you have a coalition government, right?
Mm,
But in Karnataka, do you have a coalition government?
no, Congress.
No.
So that is a which example? Primary key or opposite primary key?
Primary key.
Primary key. So single party has got that number.
Majority.
That's a primary. Do you understood primary key and composite primary key?
Yes, sir.
Okay. So in composite primary key, when a single column is not satisfying the conditions of a primary key, then you have to find the combination of two columns. Okay. And they both together will make a composite primary. Hope it is clear, guys.
Yes.
Now suppose if I have one more record here. How can you tell that apartment name and floor is satisfying the conditions of the primary key?
No.
No. Why?
Duplicate records.
Because this record and this is duplicate,
Yes.
so they're not satisfying the conditions of the primary key. So now you cannot tell that apartment name, column, and floor will make a composite primary. Is this clear?
Yes.
Are you understanding, guys?
Yes, sir.
Yes, sir.
So again, let's consider that election process. Sometimes it happens that even the two parties, they together are not able to reach that magic number. Then what they will do? They will join hands with some other party as well, right?
Yes.
So now, if you will consider this flat number, so do you think apartment name, floor, and flat number, these three columns together will make a composite primary key?
Yes, sir.
Is this clear?
Yes, sir.
Now all this three, now check this three combination. All they distinct. They're all distinct,
Yes, sir.
right? So now the composite primary key will be apartment name, floor, and flat number.
Yeah.
So in composite primary key, there is no restriction on the number of columns. Now suppose even if these three columns are not satisfying, then you have to check for four columns combination. Okay, then five column combination. As working in real estate project, we have used six column combination for composite primary key. Hope it is clear so far.
Yes.
This is known as your composite primary key. We have discussed primary key, candidate key, and composite primary key. So actually, these questions are generally asked to the freshers, a college pass out. Okay,
So what is surrogate key? Something like that.
coming to that next topic.
Okay.
Okay. Now there is a concept of surrogate. I think I have this example here. All the examples are here. 1 minute. Have I covered here? Not covered here, surrogate key. I've covered it. All the examples are present here only. Perfect, perfect. We take this example. Okay, now we'll try to understand what is surrogate. Suppose we have this employee table and this is the data. Okay, employee ID, employee name, salary and location. Now suppose Aman is transferred from Delhi to Hyderabad. So I will prepare this record, correct? Is this clear? Go on, guys, tell me yes or no. I will prepare this record, no? That Aman is now transferred to Hyderabad, and I will give this active flag Y. Y means these are active records, but I will maintain the record for Delhi as well. Because suppose if your HR wants to know that before Hyderabad, where Aman was located, so he can refer this record. Okay.
Yes.
Yes.
Yes, sir.
Okay. You might be thinking that Tanvir, you can do like this as well. No, let me show you. You can directly write Hyderabad here, right? But if I will directly write here, and suppose your manager wants to know that where Aman was located before Hyderabad, is that information visible here?
No, sir.
No, it's not visible, right? This is what I'm covering in this ETL batch yesterday. Sorry, yesterday, not last week. Those who are part of ETL batch, you can correlate, right? Same thing we have discussed. Now, so I will create two records. An active flag I will mark N. It means this is inactive record. But then why we are maintaining this? Because this will help us to understand before Hyderabad where Aman was located. Is this table clear?
Yes.
Okay. But there is a problem with this approach. This approach is clear and it is good that you are maintaining history. You have a history of Aman, no? For Hyderabad where he was located. But there is a problem with this approach. Can you think and tell me what is the problem?
Employee ID would be primary key, then we would have like a duplicate.
Now, do you think this employee is a primary key?
No.
No, sir.
No.
But here this was a primary key.
Yes.
Yes, sir.
Yes. So that is good. You're maintaining history. That is good. But the side effect is you disturb this employee ID. Now this is no more a primary key. Okay. Now for this, what we do is we will create a surrogate key. The surrogate key is a dummy column. That's very simple. It will just keep on incrementing like this. It will keep on incrementing 1, 2, 3, 4. Now suppose if you have a new record, that will become 5. Again, if you have a new record, that will become 6. It is an auto incremented. It will keep on increment. So now, do you think this column employee ID underscore surrogate key is satisfying the conditions of the primary key?
Yes, sir.
Yes.
Yes. This is known as surrogate key. The scenarios where you have to maintain history of record, obviously the employee ID column will be disturbed and you cannot make it as a primary key. So in that case, we create a dummy column. Why I'm telling dummy? Because actually this is not a part of this employee table, but it is the compulsion to create this because this employee ID column is getting disturbed. Why? Because we are maintaining history. So that's why you're creating this dummy column, which is auto incremented. And this will be always unique, which is known as surrogate key. Is this clear?
Yes, sir.
Yes.
These all are actually whatever I'm teaching you today. This primary key, composite primary key, surrogate key. These are not art. These are not part of SQL. These all are part of ETL. Okay. Now next is not null. Not null means, like suppose, take this example. Why it is throwing error message? Because in this last name column, I have given here 5. It means it can accept only 5 characters. But in last name, how many characters I'm trying to insert? 7 characters, right? So that is what engine is telling here. That will actually you're trying to insert 7 characters. Maximum capacity is 500. Now I will give 50 here. Okay. Drop the little for this report is inserted. This is the data, right?
Yes.
Suppose I'm trying to insert this report. Why it is throwing error message?
Last name is not last name should not be null. That's why, because it is mentioned in our last name should not be not null.
Is this clear to everyone?
Yes.
So here I have clearly mentioned that this last name column should be not null. It means I'm telling to SQL engine that if someone is trying to insert null value in the last name column, please don't accept it. Okay. So here when I'm trying to insert null value, in which column? Last name. That is why Indian is telling that we cannot insert null into this last name column, because when you're defining this table, here you have mentioned that in the last name null is not null, means null should not be there. Hope it is clear. So
Yes.
this is known as not null constraint. Hope it is clear, guys.
Yes, sir.
Yes.
Okay. Simple topics. Then we have unique constraint. So I have an example of unique constraint. I have to prepare one unique instant example was the authentication on the. Okay, let me show you for unique constant. Okay. Okay, unique constant. Leave it, let me show you the example. With the customer. Okay. This record is inserted, right? Now, why it is throwing error message?
Because customer name has to be unique.
Because here, while defining this customer table, I have mentioned that this customer name should be unique, right?
Mm,
Now, Rohan is already present in this customer table, correct?
yes.
Again, I'm trying to insert the same customer name, Rohan. That is why engine is telling that with unique constraint violated. You're violating the unique constraint because when you have defined this customer table, at that instance, you have told that this customer name should be unique. Then why you are inserting same record again? We will not accept it. That's why the error message is unique constraint violated. So when you are designing the table, okay, you can implement this constraints. First one is not null. If you think that no one should insert null value in this, you mark it as not null. So if someone is trying to insert null, it will not accept it. Here unique. If you want your all customer name should be unique, you mark it unique. It will not accept duplicate. Hope it is clear.
Yes.
Any question? Any question, guys?
No, Tanu.
Okay. What about null? Do you think it will accept null?
No, sir.
It will accept null.
Yes.
It will accept null. So this is the difference between unique constraint and primary key. If you will mark a column as a primary key, it will not accept duplicate, it will not accept null. Because for a primary key, the condition is no duplicate, no null. But if you have marked a column as a unique, it will not accept duplicate, but it can accept null. Hope it is clear.
Sir,
Hmm.
but in null there may be the Rohan character as well.
Ah, I totally agree. You're right. Maybe in this null, Rohan will be there. But there that are chances, right? And that is why engine considers this null different than Rohan. So if you're writing unique, so it will accept null. And one more thing I will show you. I'm trying to insert one more null. Do you think it will accept? Yes, it will accept. Check the output. This is the important point here. So if your customer name is unique, it will accept the unique values, no duplicate. I have tried to insert Rohan once more. It has thrown error message. But null it can accept. Even multiple nulls it can accept. But if the column is a primary, like see here, this employee ID was primary, and this employee table, right? See here, I will try to insert one more ID one. So this is John. Right is not accepted because you have made employee ID as a primary key. If it is a primary key, it will not accept duplicate. Already ID one is present. You are trying to insert again. That's why it is not accepted. Hope it is clear.
Yes.
Yes, sir.
Now, um, employee ID are marking as null. Do you think it will accept?
No, sir.
Why?
Because
Primary.
employee ID is a primary key.
Employee ID is a primary key, and primary key, no duplicate, no null, right?
Yes.
Cannot insert null into employee ID. Got it? Is this clear?
Yes.
Yes, sir.
So you understood what is primary key and unique constraint, not null, right?
Yes, sir.
Okay. So now we'll go with the next topic, foreign and integrity constraints. Okay. A simple one. Okay, this is the example. Suppose I have this department table. Now we're discussing. So you can see here that I have created a department table. And I have inserted two reports. Okay. This is not. Okay. Now after this, I'm creating an employee one table. Okay. This is done. So far, I have created a department table and employee one table. Employee one report. Okay. Now in this employee wanted. I want to insert one more record, this one. Point is throwing error message. Integrity constraint violated. Parent key not found. The reason is when you have created this employee one table, please notice here what you have mentioned here. You have mentioned here that in this employee one table, you want a department ID column. This is a department ID column, right? But for this column, you have written int. It means this is an integer data type. This is also fine. But then here you have written something. What is the meaning of this? The meaning is you are telling to the SQL engine, if someone is trying to insert a value in this department ID column, first of all, check whether that value exists or present in this department table and ID column. If it is present there in department table and ID column, then accept here. If it is not present here, then please don't accept. Now here this employee one table. What is the value of department ID you're trying to insert?
40. Mm,
Do you have 40 present in this department table and ID column?
No.
No. That's the reason engine is throwing error message. If it is this clear?
Yes.
Yes, sir.
Now suppose your manager is telling that no, I want this 40 this record to be inserted in this employee table. Do whatever you want. What we have to do?
Remove the reference clause from the query.
Now what we have to do, guys?
We have to remove the constraint.
Now
You have to add the department ID.
you have to add that department ID 40, right? In this department table. Now tell me,
In parent table.
in this department table, do you have department ID 40,
Yes. Mm,
right?
Yes.
Now you execute this query. Now record is inserted. Is this clear?
Yes.
Mm,
Yes, sir.
This is known as integrity constraint. Which constraint? Integrity. That means these two tables have integrity constraint. So this employee one is known as child table. And this will be known as parent table. So whenever you're trying to insert a record in this child table, first of all, it will check whether that record is present in parent table or not. If it is not present in parent table, it will throw error message. Hope it is clear.
Yes.
Is this clear?
Yes, sir.
Yes, sir.
Now the real-time application is like suppose I went to a bank. Suppose I went to Axis Bank. I want to deposit 10,000 rupees. They will ask my name, right? In a slip, they'll be having a form, right? In that form, you have to write your name, your bank account number, right? And your PAN card and other details. Correct. Suppose in the form I'm given incorrect name or bank account number. Suppose. Do you think that that clerk he will deposit this money into your account?
No.
No.
No. In form, whatever you have filled, first of all, it will check whether it exists in the database or not. Correct?
Yes.
If it exists, you will make an entry of 10,000 rupees and immediately you will get a message that rupees 10,000 has been credited into your account, right?
Mm.
But if your name or bank account number is incorrect, it will not accept it, correct? So
Mm.
what is happening? It is an example of integrity constraint. So this name or bank account number, they will check in the parent table whether this exists or not. If it doesn't exist, it will throw error message. Hope it is clear.
Yes.
It is clear, everyone. Sure, clear or not.
Yes, Tanvi.
Now suppose I want to delete this department table. Because of some reason I want to delete this. Why it is throwing error message?
The data is being used in another table.
Because this child table is referring this parent table department. So that is why it is throwing the error message that unique a primary key is in table referenced by foreign keys. So this child table is referring this parent table. It is why you cannot delete this. Now here, this is known as parent table. This is known as child table. Okay. And this department ID is referring this one. So this is known as foreign key. Okay. Suppose we are in India, we go to US, Canada, or any other place. Even our roots are in India. We are referring there, right? That is why we will known as foreigners there. So here this department ID will be known as a foreign key because it is referring this parent table and this column. Hope it is clear, guys.
Yes.
Yes, sir.
But now suppose your manager is telling that then we know we have to delete this table at any cost. So what you have to do, first of all, you have to delete this employee one table. Okay. Job table employee one. First of all, delete this one. This child table is deleted. Now you delete this parent table. This is also deleted. Hope it is clear.
Yes.
So here we complete the discussion of this constraints. Okay. And we will proceed further with the next topic tomorrow. And I'm sure we'll not be able to cover the remaining topics. Let's plan. Okay. We'll see whatever we can cover. But here, this two topics are important. Maybe I will start with recursive city tomorrow and then plan for them. Okay. Fine then, guys. Connect tomorrow at the same time. Thank you. Okay, bye.
Thank you, sir.